Question is from JEE Main 2025 Maths. Question is like this: if limit t tends to 0 of this function, which is integrand of 0 to 1 of this function 3x plus 5 raised to the power t into dx and whole to the power 1 by t, is alpha upon 5e into 8 upon 5 raised to the power 2 by 3, then alpha is equal to, you have to find out, actually it is 64. So let us see. Now our function is like this, and this you have to find out the limit. Okay, its given value is this. So let us start solving the question. To simplify the procedure, we just find the integration of this much. Okay, then we will raise its power to 1 by t. And to find this integral, we know that x is variable but t will be treated as constant over here. Okay, so you know that x raised to the power n, if you have to integrate, then you will get the answer as x raised to the power n plus 1 divided by n plus 1. That formula, the basic formula, the first formula for the integration, we will use that. So here for integration portion, we assume t as constant, and firstly we solve this. Okay, so let us solve. Definite integral 0 to 1 3x plus 5 raised to the power t dx, where t is constant, treated as constant sum. So its value will be, after integration, 3x plus 5 raised to the power t plus 1 divided by t plus 1 into differentiation of this one, so 3 will be multiplied over here. Your definite integration limit will be written over here. When you will simplify it, so 3 into 1 plus 5 raised to the power t plus 1, 3 into t plus 1 minus 3 into 0 plus 5 divided by 3 into t plus 1. This raised to the power t plus 1. Okay, so when you will solve this, you will get this one give you 8 t plus 1 divided by 3 into t plus 1 minus this will give you 5 t plus 1 divided by 3 into t plus 1. So now one portion we have completed. Now what we will do is, our limit, come to our limit. That limit was this function raised to the power 1 upon t, and limit t tends to 0. This was our purpose to be solved. So limit t tends to 0, this we have written power 1 by t. Now this is the exponent form of the limiting case. Okay, where limit t tends to 0 ft raised to the power gt. And one more special thing about this is the formation of 1 raised to the power infinity. Why? 1 by t is infinity, 1 by 0 is infinity. This is 1. How? You can see it. If you put t equal to 0 in this expression, you will get 8 0 plus 1 divided by 3 into 0 plus 1 minus 5 0 plus 1 divided by 3 into 0 plus 1 1 upon 0. So 8 by 3 minus 5 by 3 1 upon 0. 3 by 3 is 1. Power 1 by 0 1 up raised to the power infinity. When you get this type of indeterminate form, we knew the formula to be used, that this type of limiting case can be changed to this format, where limit x tends to 0 fx raised to the power gx can be written as e raised to the power limit x tends to 0. This gx will come before and fx minus 1. So base will be subtracted by minus 1 and power will come beside the base. Okay, this is the actual meaning of this formula. Okay, and this formula you must have come across when you have learned the limit chapter, so you can go and revise it also. Otherwise I have given the detail over here. Okay, so in our case fx is 1 and gx is infinity, so this formula suits to us, so we will apply it. So we can write our limit as e raised to the power limit t tends to 0 1 upon t, because power was 1 upon t, it will come beside 1 upon t, and the whole expression fx was this minus 1. Extra thing is fx minus 1 you have to do. Now take this LCM 3t plus 1 throughout. So next step you will get 8 raised to the power t plus 1 minus 5 t plus 1 minus 3t minus 3. Okay, this one remaining will be same. Now this 1 upon t can be multiplied with this one. So next step we will do 3t into t plus 1 in the denominator. Numerator no changes. Okay. Now here this again you have to check this format. Okay, what type of case is this? So if you put t 0, so 8 raised to the power 1 you will get. Here 5 raised to the power 1 you will get. So 8 minus 5 is 3 and 3 minus 3 is 0. Also minus 3 into 0 is 0. So this is numerator is 0. Here also if you put t equal to 0, then 0 into 0 plus 1 is 0. So 0 by 0 format you are getting. So we will use L-Hospital rule in which differentiate numerator and denominator individually, okay, with respect to t. Also you remember that differentiation of a to the power x is a to the power x into log a. That also you have to use, okay. So we will use in the next step. So first of all we will differentiate it, numerator and denominator individual. So limit t tends to 0, e raised to the power, limit t tends to 0. This will give you 8 into t, 8 raised to the power t plus 1 into log 8. This will give you 5 raised to the power t plus 1 into log 5 minus 3 into 1, that is minus 3, and this will give you constant 0 differentiation. Here also 3 into, suppose this is t square plus t, when you multiply, so 2t plus 1 you will get. Okay, now if you put t equal to 0, then there is no problem you will face. So you directly put t equal to 0 over here. So you will get 8 into log 8 minus 5 into log 5 minus 3 divided by, this will become 0, so 3 into 1 is 3 only. Okay, now a simple simplification is further there. We will split this denominator between these and this. So e raised to the power log 8 raised to the power 8, because this can be written as like this power, it can be raised to this power. So similarly minus log 5 raised to the power 5 divided by 3 minus 3 upon 3. So this 3 upon 3 will get cancelled, you will get 1 minus 1 over here, e raised to the power this whole. Okay, next time this 1 by 3, this 3 I have written as 1 by 3 multiplied. So again this is log m minus log n case, so log m upon log n we can write. Okay, minus 1 was already there. Next step, this 1 by 3 will be raised to this power, whole of 8 raised to the power 8 upon 5 raised to the power 5 and whole raised to the power 1 by 3. Okay, and this e raised to the power minus 1. Okay, this one step is closed. So this can be written as 1 upon e, and this e and this will get cancelled. Okay, next step. So we will be left with only this much over here. Okay, see here e, because you know e log x power, if it is there, so it will be written as x only. So we can write 1 upon e into 8 raised to the power 8 upon 5 raised to the power 5 whole to the power 1 upon 3. But according to the question, its value is alpha upon 5 e into 8 divided by 5 whole raised to the power 2 by 3. So we'll now just compare it. On comparison you will get these two will be equal, so e and e will get cancelled. Now like terms will be maximum, so 8 raised to the power 8 upon 3 divided by this 8 raised to the power 2 by 3 into, sorry, equal to alpha into this 5 raised to the power 5 upon 3 will go up, and this 5 raised to the power 1 will be added to this 5 raised to the power 2 by 3, so it will be like this. So when we take the LCM over here, 2 plus 3, 5 upon 3. So 5 upon 3 and 5 raised to the power 5 upon 3 and 5 raised to the 5 upon 3 will get cancelled, you will be left with 1, that is alpha into 1 is alpha. Here also base are same, but they are in division case, so we will subtract the powers. So 8 raised to the power 8 by 3 minus 2 by 3, which will give you 8 minus 2 upon 3, that is 3 to 0. So alpha is 64. Thank you.